Hello and welcome to the solution of one of the Leetcode problem. Today we are solving remove duplicates from sorted array. Now the problem says that given an integer array called nums, which is sorted in non-decreasing order means that when we traverse the array from left to right, the elements are in an increasing sequence or they are the same. Now we need to remove the duplicates in place such that each unique element appears only once. And the relative order of the elements should be kept the same. Now there's an interesting constraint in this problem, which is to solve it in place. Now in place basically means that we are not allowed to use any additional data structure for storage or additional memory purposes. It means that we have to have the space complexity as big of 1 only. Now if there are k elements, after removing the duplicates, then the first k elements of nums should hold the final result. And they have asked us to return k. Alright, so let's look at a couple of examples that they have. The input nums array is 1, 1, 2, so we can see one duplicate element here. And the output is 2 because we can see that we have just two unique elements, which is 1 and 2, which occupies the first two positions of the final nums array. We don't really care or bother about the next elements once we have removed the duplicates. Similarly, in example 2, we have 5 unique elements in this array. That's why the output is 5. Okay, so we have the constraint here as in place. Now, if we didn't have this constraint, our life would have been much easier. We could have used sorted set solution. So for example, we can have the nums array as this, which has few duplicate elements. Index position is from 0 to 6, so total we have 7 elements here. Now this is not an in-place solution. So when we traverse the array and put the elements in the sorted set, this is what we get after traversing the whole array. 1, 2, 3, 4. So these are all the unique elements that we have in the nums array. And inserting element in sorted set takes big O of log n time. And since we are inserting n elements, so total time complexity would be n log n. For the space, since we are storing n elements in our sorted set, that's why the space complexity is big O of n. Now this is not the solution that we want an in-place solution. So another technique that we generally use to solve array problems is two-pointer solutions. Let's see how we can utilize two pointers to solve this problem. So for two-pointer solution, let's look at this example array nums. So this array has few duplicate elements, as we can see, and the index position is marked from 0 to 6. So our first pointer, we can take it as an insert pointer. We can alias it as k. Another pointer that we can use is to keep track of the current index. So let's name it as current index pointer, and maybe the alias could be I. Now how do we initialize these two pointers? Now interesting thing to note that our array is non-decreasing, right? So the first element, do we really care about the first element? The answer is no, because this will be the smallest element in the array, right? So we don't really want to replace this with anything else. So we can start from the first index, marking k as 1, and also our current index pointer as 1. Maybe we can mark it here as well for better representation. K and I are at first index. Now the next step would be to compare I and I minus 1th value of nums. So we'll compare nums of I and nums of I minus 1. If nums of I and nums of I minus 1 is same, which is 1 in this case, then we don't really have to insert anything. All we have to do is increase our ith pointer to the next index position. So our I becomes 2, k remains same as 1. Now again we compare nums of I and nums of I minus 1, which is 2 and 1 in this case. Now this time they both are having different values, which is 1 and 2. Now when we have different values for I and I minus 1, it means that we are encountering 2 for the very first time. And then we have to insert in nums of k the value of nums of I. So our logic would look something like this. If nums of I is not equals to nums of I minus 1, then we insert in nums of k the value of nums of I. This means that we'll be inserting 2 here, and we have to increment k as well as I. So k becomes 2 and I becomes 3 here. Again we compare nums of I and nums of I minus 1. This time both are having the same value, which is 2, so we don't have to do anything and just increment the value of I, which becomes 4 now. Now again we compare I and I minus 1, which is 3 and 2. So this time we have a different values, right, for I and I minus 1. It means that we are encountering 3 for the very first time. So in this case we will replace nums of k value with 3. So this becomes 3 here, the second index, and then we increment both k and I. So k becomes 3, I becomes 5. Once again we compare I and I minus 1. So these are again two different values, 3 and 4, right? So we are encountering 4 for the first time, and then we insert 4 in the kth index. So here we have 4, and now the value of k becomes 4 and I moves on to 6. Again we compare I and I minus 1. In this case both are holding the same value 4, so we don't have to do anything and just increment I value by 1, which is 7 right now, and 7 is already the end of the array or out of index for the array length. So this marks the end of our iteration, and what we observe after the iteration is that 1, 2, 3, 4 are all in a sorted order and we don't have any duplicates, right? So we just return the value of k here, which is 4. So 4 should be the answer. I hope the solution makes sense. Let's jump on to the coding part. So we'll code the solution in Java in the Leetcode editor itself. Now before starting our main logic, we need to take care of the edge case, which could be if the length of the array itself is 0. What do we do in such case is just return 0. Next we can initialize our insert pointer with 1, and then we can start our current index pointer iteration. Right, and then we'll check for nums of I and nums of I minus 1. If they're not same, then we just replace nums of k with nums of I, and we also increment the value of k here. And if nums of I and nums of I minus 1 are same, then we don't do anything, we just increment the value of I. At the end of the solution, all we have to do is return the value of k. Let's run the code and check the result passes. Seems like our answer matches with the expected answer, and this should be the end of the solution. Now before wrapping it up, let's discuss what is the time and space complexity for the solution. So since we are iterating the whole array once, having n elements, time complexity will be big of n, and we don't use any extra space here. All we have done is just remove the duplicates in place, so the space will be big of 1. Hope you like the solution. Do like the video and subscribe to Stack Interviews channel. Thank you.